All right, folks, glad to have you here for our June webinar. And it's summer. So here we are welcoming you on the first day of summer in the Northern Hemisphere. Of course, winter in the Southern Hemisphere. Daylight in the Northern Hemisphere is going to start to decrease from this date forward. And so it's heading towards the shortest day length and the December solstice. Um, Other things to know. I put some other things on there. The Northern Hemisphere is tilted toward the sun right now, but we're also reaching the aphelion. So that's probably a term that a lot of folks aren't familiar with. Good old Earth sun geometry. You know, the sun isn't in the center of our orbit, and it's not in the center of any of the orbits that we can see planetarily. So there are times of the year when the Earth is closer to the sun, which happens around the 1st of January, and times of the year when the Earth is farthest from the sun, and that's usually around the 4th of July. So here we go with all of that going on. Other things. So if anyone was on Twitter last night, you were probably seeing a lot of activity in New Mexico. There was a lot going on, and including there was a dangerous flood on a burn scar, and there's a huge dust storm. So just a little bit about what a haboob is. A haboob is a very specific type of dust storm that happens from strong downdrafts from a thunderstorm. And that thunderstorm then, those downdrafts create a gust front that moves out ahead of the thunderstorm. The gust front can then push a whole bunch of dust or sand or both. Arizona haboobs can be very tall, several thousand feet high, and they can spread out 100 miles or more. All dust storms can drop visibility on the road, so we need to pay attention. When that happens, the best practice, of course, is to pull off the road. So then looking at May was warmer than average in every county across the state. Some counties like La Paz, Yuma, Maricopa, Pinal, Santa Cruz, they hit anomalies of 2 degrees Fahrenheit or more. It's pretty warm. Apache and Greenland counties they were still warmer, but more normal, closer to their average May temperature. So they did okay. When we're looking at the climatologically driest months of the year, that's April, May, and June for Arizona. So it's not unusual to see several counties tied for the driest May on record. Still, the state was overall very dry, ranking as the 12th driest May on record. Our state is still being impacted from very hot and dry last year months. So October, November, and December last year, very hot, very dry. So a water year is how water's managed, which starts in October and runs through the end of September. Arizona, we take into account not only precipitation, but also temperature, and that helps us evaluate our long-term drought. Oops, one more, there we go. When we're looking at the water year last year, so if we look at the October to November last year, there was a very dry October to November. And then here we go into January through April this year, there was a bit more precipitation. It kind of caught us up. And then we had a drier May. So now looking at October through May for the water year, we are just a bit below the long-term average for the state. And then looking at our short-term drought. Short-term drought, we can see we were able to improve that slightly January to April. Now we're looking at about 17% of the state in D1 moderate short-term drought, 3% of the state in D2 severe short-term drought. That D2 short-term drought's been entrenched in Cochise County. You can see it down there. A bit of Greenlee and Graham counties for a while they've been experiencing that. The D0 abnormally dry, that yellow area on the map, that's actually not considered to be short-term drought. So looking at that, we've been setting up fairly okay. The expectation from the drought monitor is that the monsoon will be dry. So that means drought levels are expected to expand again as long as the monsoon is dry this summer. So looking at the possible thunderstorm activity this weekend, wildland fire potential is expected to improve slightly. However, dry thunderstorms are expected, and that means lightning might spark wildfires. And if there's not enough precipitation, that wildfire can continue. So that's the whole aspect of what a dry thunderstorm actually is. There will be lightning, and there may not be enough precipitation to put out a fire. So ENSO conditions are, it's more a factor of our winter precipitation, but we expect to get back into a La Nina phase later this summer. We had 3 La Nina events in a row recently. So those first 2 winters were very dry. And then the last La Nina winter, which was last 2023 winter, it was very wet. So we'll just wait and see what happens. I did want to bring this to everyone's attention. If you have an In-N-Out in your area and you get a rainy day, just an FYI that the kids not only can get the best burger, in my opinion, but also get some free hot chocolate. So watch for that. We'll see what happens this summer. I do want to invite everyone for next month's webinar, and I would like to introduce Mike in just a minute. Mary Wright is the Built Environment Specialist for the Heat Ready Phoenix office. But I'll go ahead and stop sharing and let Mike come on in. And one moment there. So Mike, you can probably get ready to go. We're grateful to have our discussion with Mike again, U of A professor, specialized in climate, rangelands, wildfire, water resources, but in my opinion, the best monsoon discussion. So I'll let you go ahead and take it away.
Thanks, Erin. I'm so excited to be here, and thanks for the invitation to come back. I am a monsoon enthusiast. I can't say I'm an expert. I try. I am a transplant to the Southwest. I'm not a native. I've been here for 22 years now, and I'm still a student of the monsoon. And so I'm excited to just talk with you today. And hopefully I'm just going to spin through some broad overview slides. We'll take a sneak peek at some of the forecast information. Hopefully I have a little bit of time to talk about it, because I thought on June 20th, when we're talking about the monsoon, we'd be talking about it in the distant future. And I thought weeks away, and what a wild couple of days it's been. And just to see the radar images you were showing, Erin, too. I was watching the same thing last night, watching this outflow move all the way across, and waking up this morning, we now have the smoke and the dust cruising through Tucson. I'm not sure it's made it up to Phoenix yet, but we have the haze. I saw my dew point at my home weather station jump about 20 degrees in about an hour. And so we're here. And so we've got stuff to talk about today. And so I am going to quickly start off with just some background information on the way that I think about Arizona climate. And I really think about it as winter versus summer weather patterns. And I hope this kind of just helps us get our head around how unique the North American monsoon system is, and our sort of experience of it is here in the Southwest. And so in the wintertime, and again, very cartoony graphics, conceptual, but we in the Southwest participate in the mid-latitude weather systems that basically cruise across much of North America. And we're on kind of the far southern reaches of where the jet stream basically moves across and kind of wiggles across from Canada all the way, and it can reach all the way down into Mexico. And so we're kind of in between those waves that come across. And so that weather is coming out of the west, moving towards the east. We're getting our moisture from, can be all the way any part of the Pacific Ocean. Largely those juicy storms are going to have moisture from the equatorial regions of the tropics. And it's going to drag it in here. So it's thinking about that weather coming out of the west, moving towards the east. And so part of the mid-latitude system. The interesting thing is and here, just real quickly here, this is what the moisture sources look like. And so those dark red and orange colors are dry air, and the moist air is the cooler colors here. And so you can see here, it doesn't really show the full expanse. If we were to look deeper into the tropics, out to the west, we'd see some of that subtropical moisture, but largely the Pacific Ocean out off of the west coast is cool and dry. and we don't have a lot of opportunity for moisture to pull in there. And so we're pulling it from the North Pacific, reaching in those atmospheric rivers from the deep subtropical Pacific in the wintertime. So this gives us sort of our nice, pleasant, dry climates, fall, winter, and spring. When we move into the monsoon system, we're kind of juxtaposing this change in circulation. So that mid-latitude jet stream rises real far north up into the Arctic. It's chasing that cold air because it's going to follow the tightest gradient from north to south of temperatures. And so as that cold air sort of shrinks around the poles and the warm air to the south builds in, that jet stream is going to rise very, very far north. And so then we start to get these expansive high pressure systems that build across the continental US. And so the Bermuda high pressure system out over the Atlantic and our East Pacific subtropical high pressure system start to strengthen and expand. They move north. The upper levels have an expression of that too at the mid levels. We call about 500 millibars in the atmosphere, about 20,000 feet, are also showing us this high pressure system from the surface to the upper levels. And so the whole flow pattern around these high pressure systems starts to change the directions of the weather systems here. And so as they move north, we start to go from a mid-latitude type systems into basically subtropical to tropical easterly type systems. And so that really is that wind shift, which is what the monsoon means, is that change in wind direction. And we see this progression of these building of these high pressure systems from April, May to June. June, they sort of peak. And then we really want them to sort of move overhead and then move to the north of us to open up that flow of moisture from the south. And so if we look at this graphic here, you can see that area of red colors, which is that dry air, sort of get pushed off to the northwest. And think about California summers. They're a Mediterranean climate, so this is their dry season, and that moisture in the North Pacific is pushed way up over Canada. And then look at that nice purple and cool colors, which is that moisture reaching up out of the tropics and then riding up north towards us, which is, again, that's what the moisture expression of the North American monsoon system is. So it's a complete change in weather systems across North America. Okay, so let's look a little bit closer at the North American monsoon system. All right, and so we're just going to click through a couple of graphs here just to show you that change in high pressure systems at the mid levels of the atmosphere. So it's about 500 millibars in the atmosphere. And again, in the northern hemisphere, the flow around a high pressure system is clockwise. So north of those H's, the wind is going from west to east. South of those H's, it's going from east to west. And so just think about that clockwise circulation. And those cool colors to warm colors is going to give you an indication of where that jet stream is. So this is in May. As we move into June, the sun angle is getting higher. As Erin said, we're hitting right at the cusp of summer right now, longest days of the year. So we're getting a lot of surface heating, long days, and the whole continent is heating up. And so that high pressure system is starting to get drawn further north. And then by July, that high pressure system is really starting to be overhead and hopefully slightly to the east or north of us, which will then think about that flow around the high pressure system, which is going to be now from the east moving towards the west. And so that being on the south side of that high pressure system is the tropics at that point. We are in a subtropical tropical air mass at that point. And we're watching the air mass transition happen in real time today. I can't remember a change in the air mass this quickly and dramatically in many years. Okay, this is a lot going on here, but I just want to kind of key in here on this progression. So the rows from top to bottom are June 15th, July 15th, August, September, October. So it's the progression from the early to the late part of the monsoon. And then the columns are on that far left is that mid-level circulation system. Then the second column is average precipitation over those periods. The third column is something called precipitable water. So it's the measure of water in the atmosphere from the surface all the way up to the top of the atmosphere. And then that final column is something called CAPE, and it's convective available potential energy. And so higher CAPE is going to be meaning there's more energy for thunderstorms to basically pop up and have lots of vertical motion to give us strong thunderstorms. And so climatologically here, that progression And that far left column, the 500 millibar geopotential height, is showing you that same thing we were talking about earlier, which is where the high pressure system is to the south of us, and very quickly moves from June 15th to July 15th, climatologically, strengthens and moves north very quickly, and really centers itself over the Four Corners, or maybe over the Arizona-New Mexico line, maybe over northern New Mexico. Those are the sort of the ideal spots. If that high pressure system parks over, say, southern Arizona, we're in trouble. And we have summers like 2020 or last summer. And then as we go through the season, it pretty quickly peaks and then starts to relax to the south again. And by the beginning of September, we're pretty much out of it. We're now sort of transitioning back into a fall pattern. So it's a very quick multi-week progression from onset to peak to transitioning back to fall weather. And we see this just about every year. Is like, if we're not really in it by the beginning of August, we're running out of time fairly quickly. And all of these other graphics here sort of show you that progression from north to south. The precipitation follows the high pressure system north, which is driven by this opening up of precipitable water. And you can see how important the Gulf of California is in drawing up moisture into the low deserts. And then the Gulf of Mexico and Gulf of California moisture and really, really good monsoon seasons will kind of come in from both directions and close off and have us in a real soupy air mass. Okay, and so another way we can think about this, and this is something my thinking has really evolved on this to kind of simplify it for myself, is to think about this air mass change. And so this is just yet another way of, it's very kind of arbitrary. It's something called specific humidity, looking at the mid-level of the atmosphere. And it's basically going to give us an indication of the low-level moisture in the atmosphere. And you can trace this climatologically, this tropical, you can see how far the Gulf of Mexico really pulls that soupy air up into the eastern United States, east of the 100th meridian. But we're really looking to kind of join that air mass, and progressively, or June 15th, it's usually the south of us. By July 1st, it's sort of riding north, and we'll get pulled, and it'll really get pulled right along the Colorado River up through northern Arizona, and it kind of reaches into parts of Utah and then joins back into the Great Plains. But you can see how hard edge this is here. If you've driven to Las Vegas anytime in the summer, you can sometimes drive out of the humidity and then into that real dry desert air and then back in again. And that monsoon boundary really is what dictates bursts and breaks in the monsoon here, and also is the beginning of our season and also the end of it. As those fall systems come in September, they start to shove this monsoon boundary back to the south, and then that's kind of it. Okay, another kind of cartoon graphic, some of the key kind of pieces and parts here. Four Corners High is this big H here, and you saw on those 500 millibar maps, we're looking for that high pressure system to ideally be to the north of us or off to the northeast of us, because as long as we're on the easterly flow on the south side of that, we're usually in the action, have that opportunity to keep that moist air mass in here. If we sort of settle down, if that high pressure system settles down to, say, the boot heel of New Mexico, what we'll often see then is that dry air will start to intrude back from the northwest. It will also increase the upper level temperatures. It will reduce our CAPE, and we'll be in the humidity, and off to the northwest parts of the state, it'll start to dry out again, but we'll be trapped with high temperatures. And that's really what the heat wave was last July, where we couldn't get any monsoon convection going. It was stifling. The humidity was actually up, but we were also baking under this high pressure system. And so this is so subtle, where this upper level high sort of moves around the southwest, of whether we're going to have a good monsoon if it persists in that location, or we're going to have the bursts or breaks where it's going to be just a real disaster like 2020 or even last summer. This is a really cool study from 2018, which is actually looking at the moisture sources from it. And so these little black dots here are where they ran a model and looked at the precipitation occurring at these locations during the monsoon season. And so when they had a rain day during the monsoon season, they used a model that looks backwards in time to try to figure out where the moisture sources came. It's a back trajectory calculation type model. And so you can look across the Southwest here and see where did the moisture come from in producing the rain days at these locations. So Cedar City, Utah, in southern Utah, southwestern Utah. You can see here that the count of the events or the count of where the moisture sources were, these yellows indicate a high frequency that's where the moisture originated from. So in southwestern Utah, a real strong connection with the Gulf of California, as we'd expect, kind of reaching right up the Colorado River. There's an interesting thing here too, is that some of that moisture kind of snuck through Baja from the Pacific and was drawn up into this region here too. So the topography really matters in sort of being able to channel this moisture up into the southwest. Grand Junction, it's a little bit of a connection between Gulf of California moisture and also reaching into New Mexico and grabbing some of that Great Plains moisture from the Gulf of Mexico. And you get up in Colorado, it's mostly then Gulf of Mexico, Great Plains, as you'd expect. Levine, Arizona, right near Phoenix, it's real strong, very direct connection with that Gulf of Mexico. And as you get into the kind of right at the break point between Arizona and New Mexico, you start to then, this is certainly the case for southeastern Arizona here too, is that you can have moisture come in from eastern New Mexico, and it'll sneak through the passes, kind of following right along I-10, and be able to be a moisture source for the monsoon, as well as that Gulf of California source. And so it's really can be a unique combination of things. And so even as we start to see the storms form today, it's going to be a combination of some of this humidity that blew in with that outflow boundary yesterday from New Mexico is going to start to support storms, but it's also going to induce a Gulf surge, and we'll start to see the Gulf of California get into action. And I can't believe I'm saying this all on June 20th, which is really quite early. Okay, so just some climatological maps here, monthly average precipitation. So June is typically not a big month, right? This is, we have June 15th as our official start date, but it is usually a long stretch before we start to get into action, which really starts to really come online in very early July. July here, we start to pick up the precipitation. Southeast Arizona is definitely favored, and the higher elevation areas at the beginning of the monsoon season. As we get into August, you can start to see it sort of spreads out, starts to fill into the valleys. Phoenix has a little bit more opportunity there. We're usually in deeper moisture. Usually the high pressure system is in a good spot where it's going to allow us to have the really kind of interesting weather events that will come out of the east, will build up on the high train and move off into the far western deserts. And then by September, you can see here July, August, and September already very quickly ramping down, and we're transitioning. And so at that point, we're either having these transition events, which are the cold fronts coming in, cold fronts, cool fronts, dry fronts really is what they are in September, or a tropical storm, which doesn't happen every year, but we can have some pretty interesting Septembers if we've got an active East tropics. Here's the total across the state, which kind of puts all those months together, and it's kind of as you expect. Those higher elevation areas are definitely the wetter areas, lower elevation are drier. And then finally, just some statistics on sort of the frequency of events across here. Percent of average annual precipitation, June, July, August, September, in this upper left here. I didn't do a very good job at the color scale, but the 50%, if you get half of your total annual average precipitation in the monsoon season, is this blue color here. And so you can see this real hard break here as you drive out of Tucson towards Phoenix. You are a little more balanced as far as getting half during the winter and half during the summer. As you get into southeast Arizona, it really starts to raise up in not most, but 2/3 to almost 3/4 of that total annual average precipitation is going to come during the summer. And so real interesting gradient across Arizona as far as the seasonality of precipitation. And then that frequency of precipitation is much more frequent across the higher elevation areas. On average, every 3 days to every 2 days, you'll see activity in these areas. And then it becomes much less frequent as you get into the lower deserts. You got to have these big events that are able to reach kind of big building outflow driven convective events that will reach out into the deserts and roll across towards the west. Okay, so we're going to finally wrap up here. We're going to look at 2023 real quick. I don't want to dwell on it. It was a real bummer. And then we'll just try to take a look and try to puzzle out what's going to happen this summer coming up. Okay, so this is some preset maps I put together for the whole Southwest, so Arizona, New Mexico. And so the upper left is the total precipitation that was seen from June 15th through September 30th official season here. And to put it into context, the lower right is the percent of average. And so anything that is at that white color to green is going to be average to above average, and anything that's in the brown tones is going to be below average. You can see it's a pretty simple map to interpret. It was below average just about everywhere. And there's some pockets where if you got lucky under a thunderstorm, it may have raised you to close to average. Tucson was interesting. We had across town some places that got to average, and the airport was just slightly below average, I think I remember. But the rest of the state did terrible. And I know Phoenix really, really suffered. And that green over to the far western deserts is actually Tropical Storm Hillary that occurred in September. And so that, you can argue, is that monsoon or not? It's tropical at that point, and it's really quite a unique map to see those areas get as much precip as they did in a really poor monsoon overall. We put it into the rankings here. If this is me calculating some long-term rankings for this kind of southwest monsoon area using Prism data, and it's July to September totals. So 2023 comes in at the 9th driest out of this 120-some year record. And 2020, you can see there ranks up as the worst. 2009 also in the recent past was just slightly worse than 2023. So certainly not the worst we've seen, but also not great by any stretch of the imagination. Okay, and then what actually happened, and this is the crazy thing about the monsoon, is it's so subtle. This high pressure system, it builds every year, and if you looked at map after map, they almost look identical. And it's just the real subtle placement and position on average of where this high pressure system set up. And it looks like a kind of a chronological map. And you look down here, the anomaly in the lower right here is it was definitely stronger than average, but it was also positioned just slightly south of its optimal position. And that's really what, again, kept us right underneath the high, stifled convection, kept the moisture at suboptimal levels, and brought us that miserable heat. And so that played out in the precipitable water anomaly. So the moisture that we had available to us was kind of some strange sort of late spring, summer moisture to the north of us that was not monsoonal at all. And the tropical moisture was really held farther to the south. And so these yellow colors indicate unusually dry conditions. And so we were stuck with that. So quite subtle, putting us where 2023 was. Okay, this is the total, this is the cumulative average. This is just a terrible figure as far as the way precipitation. So this is what Phoenix saw. The normal accumulation is this kind of jagged line here, and the brown area indicates an anomaly. And this, you barely make it out, is the 5 days of precip you had in Phoenix that totaled 0.15 inches. That's really quite miserable. The dots down here indicate record highs, and so you can just see how often those record highs were reached in the 1948 to 2023 record at the Phoenix airport. Tucson, we did a lot better. We actually squeaked out it's not quite a few. We had 18 precip days when we normally get about 25. But we had a couple of bursts that were actually severe wind events, because we had sort of the dry sublayer. But they did end up putting down some wet microbursts here and there, and almost got Tucson up to, didn't, almost, is being very generous here. It wasn't almost average. It was 4.73, and we normally see about 6 inches for the total for the season. And also had those multiple heat events throughout the summer that really hit us in July, but also crept up again in late August and then again in September. Okay, so we're going to look at some of the forecasts here and try to puzzle this out together, because I don't know what's going to happen here. So I look at the Climate Prediction Center's various outlooks here. They produce 6 to 10 day precipitation outlook and an 8 to 14 day every day. They also issue a week 3-4 forecast, so that's out almost a month, but in the last two out of in a 30-day period, last 2 weeks of looking out to a 30-day period. They also once a month issue a 1 month outlook for the next month. And then the third Thursday of every month, they issue their seasonal outlook. And so the seasonal outlook is getting made right now. It might actually be out while we're talking. And I grabbed the June 20th update, today's update for the 1 month, which is the lower, but we can kind of walk through these. So in the June, so this was issued yesterday, June 25th through 29th period, you can see here that there's a strong lean towards above average precipitation expected for much of Arizona, especially Southeast Arizona over the next 2 weeks. And that extends all the way out into July 3rd. So we are in it right now with this transition that we're seeing underway happening right now. The air mass transition is happening, it's pushing into the southwest, and the upper level high pressure system looks quite favorable for the next 2 weeks, at least if the forecasts are gonna hang in there. And so it conceivably could start us to ramp up to first having those kind of dry thunderstorms, lots of wind, but hopefully the air mass will continue to moisten up. We'll actually start to see precipitation across the southwest coming forward. Interestingly, the today's update for July is it's definitely leaning below for all the southwest coming up. So we got a little bit of a mixed signal here, is that we're going to get into the beginning of July here with a lean towards an active period, and then there's a suggestion by Climate Prediction Center is that we might just back off again. I don't know. I mean, it seems like once we're leaning into it here, that's a really good sign. It's much better start than I anticipated, given the way the models have played out. And then we'll have to see how this one plays out right now. As it updates today, is what's the whole season look like here? July, September, it was leaning below. My guess is, based on what the models have been suggesting, is that they're still going to suggest that a below average monsoon is likely at this point. Okay, so what they're looking at, they look at dozens of tools, but one of the big tools they look at is the National Multi-Model Ensemble. So this is a series of global climate models. They're updated. Some of them are running every 4 hours. Some are run at different time intervals, but once a month, they will average these all together. It's the beginning of the month, and then issue, or basically not issue, but pull these together and post these graphics of what the upcoming season might look like. So this upper left is the average of all of these models, these 8 models, or actually 7 models. In the bottom here is the National Multi-Model Ensemble. And this was made a couple weeks ago for July, August, September. And you can see here, reds are indicating below average precipitation rates for the upcoming summer. And you can see here, this is a very poor monsoon circulation and resulting precipitation anomaly. So this is not great. This looks really quite bad. And these probabilistic forecasts are definitely leaning. This is where I think they're getting a lot of their energy in that, issuing that outlook for saying that it's going to be below average. And so I've been looking at this. This has been persistent for the last couple of months. And then the lower right here is the International Multi-Model Ensemble, which is another set of different models across the world and what they say. So all of these models, you can't really find a bright spot in any of these to suggest that the monsoon season is going to pan out well. But the skill for these models is not great, meaning that there's a lot of uncertainty and they don't perform real well during the monsoon season. So we have to kind of take this with a grain of salt. And so that to me is I'm a hopeless optimist, so I'm hoping this will turn out well. This is giving me a pause. But the last couple of days, it's been quite interesting. One of the models, this one called the NCEP CFS, the Climate Forecasting System issued by NOAA, updates every 6 hours. And so it's kind of amazing. It looks out for months and months and months, but it's taking in new information. And so it's been interesting to watch. And so this is one of the products. This is kind of a grainy map. Apologies, it's not super clear, but reds are bad, greens are good if you're into precipitation. And so every day it posts what the model looked like for July. And so if you just go back about a week ago, June 12th, you can see here, it really shows that these dark browns and reds over the southwest and northern Mexico. And it's quite wet along the Gulf Coast. And you get all the way to about June 17th. And then June 18th, the southwest flips. And so the last 3 days of the modeling run have actually completely flipped over for this climate forecasting system and are now suggesting average to above average conditions for next month. And so I can't tell, we'll part of it is probably that it's a bit of nowcasting, or at least reaching into what we're seeing in the 2-week models now, that the beginning of July looks wet. So that may tip the month in towards the lean it. But I think the big question now is does this persist? Is this a blip, the beginning of the season, and are the models picking up on something much bigger and broader that is persistent and will continue through the rest of the season? The CFS, at least of the last couple of days, is changing its mind. So I don't know. If we continue to watch this, will it change its mind back again? And I'll be really looking to the beginning of July to see if that if all of these models sort of reorganize. And again, I think it really stems to how subtle that high pressure system looks across the Southwest. And if they get it in just the wrong spot, it changes kind of everything for the whole season. Okay, so just to close it down here, Arizona's unique seasonal transitional climate, kind of we talked about those first 2 slides, different winter versus summer precipitation mechanism. That really is what the North American monsoon system is that shift in summer of drawing in subtropical moisture, it's about the moisture boundary in that air mass transition. And we know they're highly variable in space and time. So we can even have a situation where we have all of the moisture in place, but if the high pressure system's in the wrong spot, it can stifle. We can have a lot of scattered thunderstorms. Some places can do well, some places may not. And we do see a lot of variability from year to year, but we really haven't sort of set up in a trend in any meaningful way at this point. And so we're just, again, I think it's been such a wild set of seasons since 2020. And so last summer was dry. I really just don't know how this season's gonna pan out, but I'm really cautiously optimistic, at least at this point, just seeing what's happening today. So I'll stop there, and I'm happy to take any questions if we have any time, or happy to talk about anything, Erin, you wanna chat about.
Love that discussion. One of my favorite monsoon enthusiasts, for sure. Oh, there's a question here about the moisture from Tropical Storm Alberto. So, I mean, yeah, there's some of it that we can get in here. What do you think there, Mike?
Yeah, I was looking at some of the maps, forecast maps the last couple of days, and then looking at the recent refreshes, is that what's really quite interesting is that watching that tropical storm form, it was huge. It was massive. It was a broad tropical trough, and there's a high pressure system over the eastern US, which is causing that heat wave. And it's this giant broad area of moisture that's being sort of directed towards us. And so it's kind of part of it. It's just broad of this enormous moisture source coming out of the Gulf of Mexico, moving all the way across northern Mexico and into the Southwest. If you look at the forecast for the next couple of days, that tropical storm will cut across Mexico. It'll go right across the mouth of the Gulf of California. And I think it's part of a weak Gulf surge that's actually being induced as well. And so it's got these kind of really nice reinforcing elements, maybe not direct drop for drop moisture from the tropical storm, but definitely helpful.
Yeah, we'll take whatever moisture we can get always
Exactly.
in that case. Yeah.
Yeah.
Right. So let's see, we've got 12 UTC GFS model just posted. Looks awesome for the monsoon for the next 16 days, if you can believe it.
I know.
Right. I know. This is what it is. And we were chatting before about the CPC, and I look at the CPC outlooks all the time. You do as well. And so I was remembering 2022 when I was watching how we were going to get such a great monsoon, and they were forecasting that the outlooks were in May, already saying it was going to be a moist monsoon. I couldn't believe it. I didn't believe it until it happened.
Me too. Me too. Yeah, me too.
So, but they did just post their July, August. Wait, no, the July, August, September. Yeah. So they put that out today, and it's not looking good.
Yeah.
For the overall monsoon. But I think everyone should remember that just because we're looking at these outlooks that are very broad, it doesn't mean that you're not going to get any precipitation. It's more than likely everyone's going to get some measure of precipitation. It's just not going to be enough to make everybody happy all the time, right?
I think that's such a good point, is that it's not binary, right? It's not like it's a complete shutdown. It'll be 2020 all over again. It might lag what you need to meet average. And that's how these forecasts are doing, is that the climate prediction forecasts are tercile based. And so they're big bins of where precip could fall. And so they're also probabilistic. So they're leaning, saying, yeah, out of 100 chances, you're now, 45 of them would be now in the dry bin, but you still also could fall in the average or above average bin. And to your point too, is that even during these driest of monsoons, like last year, there were spots with flash flooding, important impacts locally, and places that were fine, like they got enough precip. And that's the real challenge, is sort of characterizing precip here across Southwest.
Exactly that. I mean, Hillary, like we talked about, like you talked about, I mean, Yuma just went to town.
Totally.
It was crazy going on there. Are there any other questions that we're dealing with here? So is there
I do.
oh,
Thank you, Mike.
There.
Thank you,
Eleonora.
Eleonora from Tucson. Thank you. This was very clear and informative. And it's just, sometimes I giggle how much effort we scientists put into trying to understand this very complex climatic or weather system. I was wondering, and sometimes in some meetings I go to, we kind of go back to what my grandfather, I'm from Argentina, and I grew up listening to my grandfather saying, oh, this happened in nature, so it would be dry or it would be wet. And because we use the past as a proxy sometimes, because we don't know any better. But that's a comment. My question is, Mike, do you know, or is there a sense of how long it will take the scientific community to be able to refine the models using convection permitting models? When because we need the computational capacity to do that. Do we have any idea how long it will take? How many years? Would be decades? It would be just to get there, to be able to really simulate the processes at the scale that's needed.
Yeah, that's such a good question, Eleanor. So I think, and locally here at U of A, the Hydrology Atmospheric Sciences is running the WRF model. And to me, like, I'm, again, as an enthusiast, I hang on the local WRF model runs, which are run at 1.8 kilometers. And they're ingesting different initial conditions from different larger graded models. That's really good. I mean, and the challenge is that it's really good at kind of a 12 to 24 to 48 hour range, and it does really, really well. And as you follow the updates, as the larger models update their initial conditions, the model reorganizes. So it's like the GFS global forecasting system model, which is at that global scale, is struggling to get initial conditions right, and then follow the evolution of the previous day, and then translate them, and then WRF's got to run again. And so it's like this constant swirl of scale issues that kind of feed back up and then back down again. I don't know. Like, I'm not sure. We'll have more computational power. We'll be able to run more models from an ensemble basis at smaller scale. I think that will really help a lot. And so that's going to get, I think, better resolution at smaller scales and at shorter time scales. But the seasonal part, I find really, really interesting. And, to me, as we kind of puzzle through looking at, season to season, and if you just use the 500 millibar map to try to understand what happened this season, it'll lead you astray almost every time, because it's so subtle. It's like, well, it's like 25 miles from where it was one other season. It should, you have a completely different outcome. And so I'm excited about the increasing in power and the use of WRF at the short time scales, but I think we're going to struggle at the weeks, like week 3, 4 to months for a long time until we figure out, maybe machine learning is gonna help us get at that.
That was my second
That's
question.
where I was.
Yeah.
Yep, that's where I was going to go to.
Yeah.
I'm kind of a curmudgeon now. I think at this point is that, machine learning it's statistical, and all of us that have done sort of statistical analysis see the limitations of that. So I'm going to have an open mind, and I want to see what we can squeeze out of that. I think one of the things we often struggle with is just the data we feed into machine learning isn't very good. You know, it's like we don't actually have really good historical data of even where it rained or where it didn't, or even well-resolved atmospheric patterns at the resolution that you need to actually really squeeze out an interesting nuanced relationship. A lot of our analysis data is mediocre. And so it's like garbage in, garbage out. So yeah, I don't know. That was a very long way of saying I'm not sure.
Yeah, I think that's kind of how we all feel about it, right? As well.
Yeah.
Thank you for that. I appreciate that question, and that was a great discussion. Gretel, hi Gretel, good to see you. So her question is there a record of early onset monsoon in the Southwest and how that carried out into late summer and fall precipitation? I have opinions. Let's go to the favorite monsoon.
Well, I
No,
mean, Erin, you wrote the paper on this, so I'm going to yield to you.
I don't know. So here's the thing, it's when we're looking at what does that mean for early onset monsoon, that really is looking at, are we getting that precipitable water? Are we getting those dew point temperatures, the low level precipitation? Cape is not my friend, but you know, we take it into account as well. So looking at all of those ingredients that come together, the sooner it happens, the more likely you're going to get more precipitation. That tends to be statistically what we see. It's not always a guarantee though. And so, you know, it is kind of exciting to see everything kind of coming in right now, but it could just all die out for a while too. So we'll just have to wait and see. But statistically, climatologically, early onset tends to have a little bit more precipitation. So
yeah, I'll add on to that too. Is that, you know, I kind of think of the monsoon as in 3 acts too. You know, the July is the ramp up, and it's got its own kind of flavor because it's transitioning into trying to moisten up the atmosphere, and the storms are a certain character. August is peak, and you're usually kind of in the super mass, and the storms can be more widespread. And then September is the transition in the tropical, and so like they often don't correlate with each other real well. Like, and I think that's from your work, Erin, is the July and August can kind of hang together and speak to each other, but September is kind of a wild card. And we'll look at monsoon totals historically that are like 80% tropical storms, and you're like, meh, is that really monsoon? It's kind of the way that we, you know, lump or split the statistics.
Yep, that's exactly right. I mean, last summer was just, I mean, that was a great discussion, description that you had about, you know, it just, we couldn't get it going. And last June, if everybody remembers, last June was so darn cold. So we really didn't get things going, ramping up. And so August, and that's when we had Hillary come on in. But then September's trying to do it as well. Like, come on. September actually ended up being kind of average.
Yeah.
So all of those things that happen right in through there. We've got a question here. Hi, Kevin. I'm new here. Is there any plan in place for collecting precipitation from the storms to help with drought? Okay, so, you know, that's an interesting kind of thing as well. And we'll both talk about that, I'm sure. But when we're looking at getting rid of that drought, that short-term drought, long-term drought, Arizona is one of the, I think we're the only state that actually evaluates what's been going on with long-term drought. And so that is entrenched. If we look at precipitation in the last 30 years, we've had some good years, but for the most part, we have had too many deficit years. So that's going to take a while to come in. When we're looking at precipitation, like getting that precipitation in the summer, really that's helping the ecological systems. It's making sure that the moistures in you know, the top portion of the soil, it doesn't really help our water supply. We really need that winter precipitation, but I'll let you talk a little bit too, Mike.
No, that's exactly what I always tell people too. It's like there are different flavors of water. You know, the summer water is because the evapotranspiration is so high, is that the water comes into the system. It doesn't usually hang around for very long. And so, I mean, our sort of interest now in water harvesting is kind of thinking very old ideas and bringing them into the present of like, well, we could actually hang on to that water and possibly use it rather than kind of letting it run out and then just evaporate into the atmosphere. So, but yeah, just like you said, Erin, is that the way that we actually recharge water supplies in Arizona, it's the winter. Like we just don't do it very effective. We can. 2022, I think, is we actually did see some rises in some of the reservoirs in central Arizona, but you cannot plan on that.
Yeah.
Those are very few and far in between.
Yeah, absolutely. Well, this is just a great discussion. Fingers crossed for a great summer. But yeah, pay attention. Everyone pay attention, keep people safe, understand what's going on around you. I think that's one of the bigger things as well. So thanks everyone for coming. We're going to go ahead and stop our recording, and I hope to see everyone next month.